So the only one I really wanted to talk about was number 3. So if you could just look at that one with me. And it wasn't even the calculus for this one. It was the, the algebra of simplifying it. All right, so for the first term, derivative, oh gosh, this is really a bad glare there. Let me darken that up. Derivative of exponential is itself, and then you have to do a chain rule for the 4x. So you're going to multiply on a 4. So it'll be 4e to the 4x minus, and then this will be 5y to the 4th dy dx. And then derivative of ln of x is 1 over x. And so then you just need to get dy dx by itself. So we're going to subtract over this term. That'd be 1 over x minus 4e to the 4x. And then the last step would just be to divide by the negative 5y to the 4th. And you're going to have a fraction in a fraction. That's okay. Don't worry about it. Like, just leave it alone. This is totally acceptable as a final answer. The common mistake I saw on that one is people brought this x down to the denominator. You can't do that because this entire thing is the numerator. So you can't just move it for that one term. If you did want, if it really bothered you so much and you wanted to get rid of this fraction inside of the fraction, and I had some people do this, you have to multiply all 3 terms by an x. You can't just move it down for that one term. That's algebraically, you just can't do that. But if you did want to multiply all 3 terms by an x, that would give you 1 minus 4x e to the 4x over negative 5x y to the 4th. And that would be mathematically equivalent. So both of those would be correct answers, but you can't just move that x for like one term. All right, and then I will also do the bonus. So the bonus question, we have find k, that's our goal, and k should be a value. It should be a numeric answer. So k should just be a number. So that y equals 4x minus 9 is tangent to this function. So this is a parabola, and then we have this line that's going to be tangent to it. All right, so this is slope of a tangent line. We're going to do a derivative. So hey guys, what is the slope of this line? That's what we're going to start with, is slope of a tangent line. So what is the slope of this line here? Yeah, good. That slope would be 4. I was hoping for more answers there, but good. 4 is the slope of that line. Are you guys with me here? Remember from Algebra 1, y equals mx plus b? For like probably 16 months of your life in Algebra 1, it was just y equals mx plus b. That slope is 4, and slope of a tangent line is derivative. So we're going to get this derivative and set it equal to 4. And so this derivative would be 2x. The common mistake I saw there is people wrote 2x minus k. K is just a number. This is a constant. So that derivative is going to be 0. That's going to go away. So this is our derivative. We're going to set it equal to 4. Again, that's the slope of the tangent line. And then, so x is 2. And you're probably like, Miss Cole, but we want k. We don't want x. Okay, I'm getting there. You have to find x and y first before you can get k. All right, so if we plug in 2 for x here, this would be 4 times 2 is 8, minus 9 is negative 1. And now that I have both x and y, I can plug them into this function and solve for k. So the f of x is the output, that's y. So that f of x is going to be negative 1. And then we're plugging in 2 for x. So 2 squared is 4 minus k. And so we're going to subtract 4. And then the negatives will cancel. So this was the final answer. K is 5. And I just want to show you on a calculator what this is going to look like. All right, so I'm going to go to y equals, and I'm going to type in this parabola. So since we found k was 5, this would be x squared minus 5. And then the tangent line is 4x minus 9. And so let's just take a look at that. Here's the parabola, it moved down 5, and then there is the tangent line. So it comes by and just sort of like kisses the graph at that one point. And this was the point of tangency, 2, -1. So like right there. All right, and then I'll do a few. If you guys would like to ask me for some, someone asked for number 6, so that's going to be the next one we look at here. This was the one about the cone. So it says the cone is being filled up with water at 3 cubic feet per minute. So that is the rate for the volume, and you can use the units to help you. So the cubed tells us that we're talking about volume. And then we're told the radius is 1/3 the height. And we want to find the rate of change of the depth of the water. So I'm going to use h for height for that, dh dt. Some people put d for depth. That's fine. It's just the formula has an h in it. So I'm going to go with h. And that should be positive because it's filling up. And it says when the depth, or the height of the water is 6 feet. So that's all the information from the problem. Here's the formula that was given to you. And the problem is we have an R and we have an H. So we need to get rid of R because we do not have any information about that. We have information about the height, but we don't have any information about the radius. So I'm gonna plug in this 1/3 H for R. So I'm gonna take out R and put in 1/3 H. And then we've got these few steps of algebra to simplify this down. First, I'm going to square everything that's in the parentheses. So that would give us 1/9 h squared. And then I'm just going to multiply this stuff together. So 1/3 times 1/9 would be 1/27 pi, and then we'll have h cubed. So you have to do, these 3 steps of algebra here before you can get to the derivative. But now I have this really simplified statement. So I'm going to do dv dt, and we're going to bring this 3 down. You can leave it as 3/27. I'm going to reduce it because most of you did, and if you're following along with your work, I'm going to try to make mine match yours. 3/27 would be 1/9. But again, you could leave it as 3/27. It'll drop a degree, and then dh dt. And then we're just going to plug everything in. So dv dt is 3, and then h is 6. Now, what I would suggest is just take all of this and divide it to the other side. You would have 3 over all of that, and then the units are feet per minute. This was cubed because it was volume rate. We just did a rate for the height, so it would just be feet, not feet cubed. So feet per minute. Now, if you did simplify it, so let me go back to this step here. You would multiply this 9 over, so you would have 27 equals pi times 36 times dh dt. And I'm just going through this because a lot of you did, so I want you to be able to check what you had here. So you just multiply that 9 to the other side, and then we're going to divide by the 36 pi. And then 27/36 will actually reduce as well. That'll be 3/4. So 3 over 4 pi feet per minute if you completely simplified, which again, you didn't have to do, but I'm just going through that because a lot of people did. Yeah, just don't bother simplifying it. It just isn't worth it, because if you mess any of this up, then it's going to be wrong, So just take all that mess and divide it over. And the only time you'd have to simplify is if it's multiple choice, because you have to keep going until you get one of the choices. But usually at that point, you can like narrow it down based on what the choices are they have. All right, now I'm going to do 2 more, and I had someone put in the chat 7 and 8. So I'm gonna do one of the, I just want other people to be able to chime in too, or do you guys all want 7 and 8? Is that collectively what you guys want as a class, or does someone want to ask about a different one? Because I'll do 2 more. Works for me, okay. And of course, if you want to go over any other ones, I will be more than happy to do that in office hours. That is not a problem. All right, so 7 was the ladder problem. So this is a 20-foot ladder leaning against the wall. The ladder is not growing or shrinking, so that's 20 feet, and it's sliding down the wall. So the top of it's going down, and the bottom of it is sliding out. So we are told the top of the ladder is moving down 0.5 feet per second. So that's the rate at which y is changing. So dy dt is negative 0.5 feet per second. And a lot of people just miss that negative sign, so just be really careful with that. The reason it's negative is the ladder's sliding down, so that y distance is getting smaller and smaller. So negative 0.5 for that. How fast is the base of the ladder sliding out? So dx dt is our question mark. And that should be positive because the base is sliding out, so that distance is growing. And then we have pause, so let me read through. When the foot of the ladder is 9 feet from the wall, so when x is 9 feet. So that's all the information we were given. Relationship between the variables is going to be x squared plus y squared equals 20 squared, which would be 400. And then derivative will be 2x dx dt plus 2y dy dt equals 0. And if you go through and divide everything by 2, 0 divided by anything is still going to be 0. So you can cancel out the 2's. And then we're going to plug everything in. So x is 9. And dx dt is what we're trying to find. And y we don't have, so I'll come back to that. And then dy dt is negative 0.5. So if you're missing something, you're going to take what you have, which we have x is 9, plug it into the original equation. So 9 squared is 81 of plus y squared equals 400. And then we're going to subtract over the 81, which is going to give us 319. And that's not a perfect square, so just leave it alone. And then the last thing we have to do is get dy dx by itself. Now this term is negative. You know, let me go ahead and erase the negative here and just put it out front. That whole term is negative because that 0.5 was negative. So when I move it to the other side, I'm adding it over. So it's going to be positive when I move it to the other side. And then the last step would just be divide by 9. And then the units are feet per second. Now, because this was a half, if you wrote that as a fraction instead, you can bring that 2 down to the denominator. So you could have had square root of 319 over 18, and that's fine too. The reason you could bring that 2, if you wrote this as a 1/2 down to the denominator, is that there wasn't a third term. To compare and contrast that to this other example we did, this one had 2 totally separate terms in the numerator. So that's why you could not do that here, but you could do it here if you wanted to. There wasn't like a plus something else going on there. All right, and then number 8, this was the baseball one. We'll draw a baseball diamond. And it's 90 feet on each side. No one's picking up the bases and running around with them, so those are all constant 90 feet on each side. The batter is running from second to third. So this is second and this is third. So he's somewhere in between here. It's not going to be to scale. I just put him in the middle there somewhere. And we're given the rate at which he's running. It says find the rate at which his distance from home plate is changing. So I'm going to connect him to home plate. And then this is the triangle that we want to focus on. So this distance is a constant 90 feet. Again, no one's picking up home plate or third base and running around with them, but I do need variables for the other 2 sides. And so it says he is running at 17 feet per second. So that's going to be my dx dt. He's running this way, and it'll be negative because that x amount is decreasing. He's getting closer and closer to third base. So dx dt is negative 17 feet per second. And we want the rate of change for his distance to home. So dy dt is the question mark. It should be negative because as he's going this way, he's going to be getting closer to home. So that distance is shortening. And then we're going to pause. It says, sorry, I'm trying to read through it here. When he is 12 feet from third base. So that's when x is 12. He is 12 feet away from third base. I know the one we did on the study guide, you were given like the other distance and you had to subtract it from 90. That wasn't the case here. I just went ahead and gave you that distance. He was 12 feet from third base. So this will be Pythagorean theorem, x squared plus 90 squared, which is 8100, equals y squared. And so that's 2x dx dt. This would be gone, that's a constant, equals 2y dy dt. 2's are going to cancel, and then we're going to plug everything in. So x is 12. dx dt is negative 17. Y we are missing, and then dy dt is what we're looking for. So I'm going to go back to this original relationship and plug in x is 12. So 12 squared is 144. And then if we add those together, that's going to be 8,244, which is not a perfect square, so just leave it alone. And so the only other thing you have to do is divide that over so that you have dy dt by itself. So it'll be 12 times negative 17 over square root of 8,244 feet per second.